Alright, so we're back with Java and continuing with using objects as parameters. So far, we've only been using simple types of parameters to methods. However, it is both correct and common to pass objects to methods. For example, consider this. Okay, we have class int a, int b, then we have an object of test. Okay, so return true if o is equal to the invoking object. Okay, right, so we have class pass object. Alright, anything else? Okay, so we'll go with second. This is argument passing. So I'll start with first one is pass object dot java. Right, so first we have okay is equal to. Okay, so we define a variable. Alright, so we start with this demonstrates passing objects as arguments. Alright, so we have a class test and then we'll have two variables int a and b. Comma int j constructor. Right, so a equals I and b equals j, and then we create return true if o is equal to the invoking object. Okay. Return true if o is equal to the invoking object. So we'll go with sorry, I don't want to buy. We'll go with boolean is equal, this is equal to. Okay, with equal to, and then we pass an object of test, right? Then we check, then we can go return o dot a equal a, or I should say this dot a, no, right? And o dot b equal b. Right, then we have a class pass object. We will define the main function here with public static void main string args. Okay, then we create three objects test, this is ob1 ob2 and ob3. Okay, test ob1 equals new test. I'll go with 1 comma 1. This is, we'll say 0 comma 0. This is ob3, this is ob2. Then we check if these are equal. System, okay, equal with this. Okay, so system dot out dot print line equals ob2 is ob1 dot equal to ob2 ob3 and here as well ob3, and let's try true and false. Right, great. Okay, so as you can see, the equal to method inside test compares two objects for equality and returns the result. That is, it compares the invoking object with the one that is passed. If they contain the same values, then the method returns true, otherwise it returns false. Notice that the parameter O in equal to specifies test as its type. Although test is a class type created by the program, it is used the same way as Java's built-in types. Okay. Where the most common uses of object parameters involves constructor. Frequently, you will want to construct a new object so that it is initially the same as some object. Okay. To do this, you must define a constructor that takes an object of its class as a parameter. Alright. Okay. So here we have box double. Okay, it takes an object, right? Okay, and it does the same. Okay, as you will see when you begin to create your own classes, providing many forms of constructors is usually required to allow objects to be constructed in a convenient and efficient manner. Okay, so we can have a new. I think I should copy the box. Is the box here? No. This box here? No. This box here? Yes. Yes. Okay. So we copy this. We come back here. We create a what did you call your main function? Overloading constructor 2. Okay. Yeah, overloading constructor 2.java. Alright, no problem. We copy this and we paste it here. Okay. Example of overloading constructor such that it is a copy of an existing object, right? So we have this. I'll go overloading constructor 2. So I'll create one more. Copies values from an existing object. So we go box box B, and we go width equals b dot width, height equals b dot height, and depth equals b dot depth. There we go. So I have this. I can create a new box b4, which is a copy of b3, and then I can do b4, and this should work. Can't find overload const 2. Oh, there we go. Okay. A closer look at argument passing. In general, there are two ways that a computer language can pass an argument to a subroutine. The first is call by value. This approach copies the values of an argument into the formal parameter of the subroutine. Therefore, changes made to the parameter of the subroutine have no effect on the argument. The second way an argument can be passed is call by reference. In this approach, a reference to an argument, not the value of the argument, is passed to the parameter. Inside the subroutine, this reference is used to access the actual argument specified in the call. This means that the changes made to the parameter will affect the argument used to call the subroutine. As you will see, Java uses call by value to pass all arguments. The precise effect differs whether the primitive type or reference type is passed. Okay. When you pass a primitive type to a method, it is passed by value. Thus, a copy of the argument is made, and what occurs to the parameter that receives the argument has no effect outside the method. Okay. So this does void meth. Okay, so this does nothing. Then we have call by value. We do it and nothing happens. Okay. As you can see, the operations that occur inside meth have no effect on the values of a and b used in the call. The values will not change to 30 and 10. When you pass an object to a method, the situation changes dramatically because objects are passed by what is effectively called by reference. Keep in mind that when you create a variable of a class type, you are only creating a reference to an object. Thus, when you pass this reference to a method, the parameter that receives it will refer to the same object as that referred to by the argument. This effectively means that objects act as if they are passed to method by use of call by reference. Changes to the object inside do affect the program here. Alright. So for example, consider the following program. Then we have a test object of okay, so we have pass object reference. Right, okay. This program generates the following output. Here we go. As you can see, in this case, the actions inside the method have affected the object as an argument. Remember, when an object reference is passed to a method, the reference itself is passed by use of call by value. However, since the value being passed refers to an object, the copy of that value will still refer to the same object that its corresponding argument does. Okay. Then we have returning objects. Maybe I should write one call by value, right? This is test, right? With call by val and ref.java, and let's copy this as well. Okay, so this is void call by ref. So we pass an object and then we do o dot a times 2 and o dot b. What was that again? Okay, divided by 2, 15 and 20. 2. Okay. And then we have, okay, question to call by ref. We have void call by value, and I comma j. Now it was simple, right? Yeah. Oh, and I comma and j. Okay, so I times equals 2 and j equals 2. Okay. Function to call by value. Then we have public static void main string args. Okay, a equals 15, b equals 20, and we will also create an object test. Maybe I should create these functions within this class, right? Yeah, that is better. Okay, so we create test ob equals 10 comma 20. All right, then we will call by val a comma b, and we have call by ref, and we pass in ob. Okay, then we will check the effect. Go, all objects are passed by reference. A and B, A, B. Test A and B as ob dot A ob dot B. Non-static method. Oh, my bad. Static. Static. Cannot find symbol. Test. You cannot find test. There it is. Class test, my man. Violation. Cannot find symbol. Test. Method test. Location. Call by val and ref. This is call by object test. Oh, what did I do wrong here? Dot meth. Oh, both. Okay. All right. All right. go ob dot go with ob dot. Don't I have this? Okay, it ends here, it ends here. Class call by val and ref. Then I have a class test. Okay, hold up. Java C. Yeah. Oh, sorry, my bad. I have to use new. Yeah, new. That was the problem. Okay. Okay, then we have returning objects. So a method can return any type of data, including class types that you create. For example, in the following program, the increment by 10 method returns an object in which the values of a is 10 greater than it is in the invoking object. Okay. Right, okay, as you can see, each time increment by 10 is invoked, a new object is created and reference to it is returned. Okay. Turn temp ob2 ob2 1222. Okay. So a new object is created and reference to it is returned to the calling routine. The preceding program makes another important point. Since all objects are dynamically allocated using new, you don't need to worry about an object going out of scope because the object in which it was created terminates. Because the method in which it was created terminates. The object will continue to exist as long as there is a reference to it somewhere in your program. When there are no reference to it, the object will be reclaimed the next time garbage collection takes place. Okay. So we have recursion. Java supports recursion. Recursion is the process of defining something in terms of itself. As it relates to Java programming, recursion is the attribute that allows a method to call itself. A method that calls itself is said to be recursive. Okay. The classic example of recursion is computing the factorial, okay, n into n minus 1. And into factorial of n minus 1. Return 1. The classic example of recursion is the computation of factorial of a number. The factorial of a number n is the product of all the whole numbers between 1 and n. For example, 3 factorial is 1, 2, 3 or 6. Here's how a factorial can be computed. Okay. So if you're unfamiliar with the recursive methods, then the operation of fact may seem a bit confusing. Here's how it works. When fact is called with an argument. Okay. What should I? Okay. Write object. Okay. We can do that. Server. Object.java. So I have to create, let's take a test, class test, and it will return the class test. Let's have this a equals I. Then I can return a new object whose value is 10 greater than current invoking object. Let's get rid of B. So what do you call, okay, increment by 10. So we are going to return an object of class test and by 10 we pass in okay. So we first will create a new object, right? So we'll go test temp equals new test, which is a plus 10, a plus 10. Then we will return temp. Then I can have a class red object, go with public static void main string args, and then first I'll create an object, let's say 10, 20, okay. Right, so ob1 a is this is ob1 dot a. Then we create a new object, ob1 dot by 10 ob2 ob2. There we go. Right, then we have recursion. Okay, so I think argument passing is done. I should create a new recursion, right? And we can write a factorial program anything else? Okay. Alright, so a fact is called 100%, otherwise it will return the product of factorial n minus 1 into n. Alright, so we have to evaluate this expression, fact is called with n minus 1. This process repeats until n equals 1 and the calls to the method begin returning. To understand how fact method works, let's go through a short example. When you compute the factorial of 3, the first call to fact will cause a second call to be made with an argument of 2. This invocation will cause fact to be called a third time with an argument of 1. This call will return 1, which then multiplied by 2, the value of n in the second invocation. This result is then returned to the original invocation of fact and multiplied by 3, the original value of n. This yields the answer 6. You might find it interesting to insert println statements into fact which would show it would label each call is and what the intermediate answers are. When a method calls itself, new local variables and parameters are allocated storage on the stack, and the method code is executed with these new variables from the start. As a recursive call returns, the old local variables and parameters are removed from the stack. The execution resumes at the point the call inside the method. Recursion methods could be used to telescope out and back. Okay. Recursive versions of many routines may execute a bit more slowly than the iterative equivalent because of the added overhead of the additional method calls. A large number of recursive calls to a method could cause a stack overrun because storage for parameters and local variables is on the stack and each call creates a new copy of these variables. It is possible that the stack could be exhausted. If this occurs, the Java runtime system will cause an exception. However, this is typically not an issue unless a recursive routine runs wild. The main advantage of recursive methods is that they can be used to create clearer and simpler versions of several algorithms than can their iterative examples. For example, the quicksort sorting algorithm is quite difficult to implement in an iterative way. Also, some types of AI related algorithms are mostly implemented using recursive solutions. When writing recursive methods, okay, you must have an if statement somewhere to force the method to return without the recursive call being executed. If you don't do this, once you call the method, it will never return. This is very common error in working with recursion. Use print line statement liberally during development so that you can watch what is going on and abort execution if you see that you have made a mistake. Here is one example of recursion. The recursive method prints array method print array prints the first I elements in the array by value. Okay, so we have print. Okay, so we create int values is int I. Values of int I, then display array recursively. Okay, so if I is 0 return, else print array this. Okay, so it will return here. Its call goes back to the system, back to the system, back to the system. Then finally return else print array. Okay, so system I minus 1. Okay, so we create a new generates the following output. I think I'm almost there. This time, okay, introducing. Okay, I'm halfway there. Introducing access control. Alright, I'll try to finish this chapter this week. That would be great. Okay, so we are recursively printing values of an array. Okay, so I am here in recursion, right? So first let's create Pictorial. Right, so I will create class Factorial. Let's create a static function fact and n, right, and then we'll go if n equals 1, then we return 1, else it's return n times factorial of n minus 1. Right. So public static void main string args, then okay, so I will try to print directly fact create a variable I, right, is fact of I. So I'll go into I equals 3 and I can maybe run this. Oh, static invalid method declaration. Oh, sorry, I static int. My bad. Okay, return 1. Yes. Alright, so factor 6. Then we can 5. This is 120. Great, great, great. Okay, then I want to recursively print the array. Right? Yeah. Okay. So they create they create the array with that size. We go 0 else we got this I minus 1 equals okay. If I equals 0, then we return, else we call this function. We call this function with I minus 1. Okay, so basically it is 10, then 9, 11, 12. And else when this condition comes, we come out and everything gets printed. Okay, well, this is actually more confusing. Alright, then let's take a funky look. Okay, this is recursion 2. Okay. Okay, so recurse. Right, so I'll have an okay, this is values array. Alright. And in the recurse function we take integer I and then we create a array of that exact size, right? New int of I. Alright, then we have print array function void and array takes nothing. Alright, or alright, so we have takes an integer I, right? The if I equals 0, then we return, else we will call the same function with I minus 1, right? And then after multiple calls they will move they will try to execute the next statement, which should be a print. Okay. Dot print. So we have I minus 1. I minus I minus 1 plus, and then I can write values of I minus 1. Right. Okay. And that should be it. So create class. Uh, okay, then we continue with our recursion 2 class. Go public static void main string args. Right. And then first we'll create a recurse r equals new recurse, let's say 10. Then for int I equals 0, I less than 10, I plus plus, there you go, r dot values of I equals I, and then we want to print array 10. So let's see. Print array I minus 1. Okay, maybe I should just keep it I. Yeah, this should be I. Okay, because it is already subtracting 1, right? Okay. I think for the uppermost, yeah, no, this should be I minus 1, because for the, if this is 10, for the uppermost level this will be, if this is 10I, which is not in the range. So we learn Java, and there we go. Okay, great. Then we have introducing access control. As you know, encapsulation links data with code that manipulates it. However, encapsulation provides another important attribute, access control. Through encapsulation, you can control what parts of a program can access the members of a class. By controlling access, you can prevent misuse. For example, allowing access to data only through a well-defined set of methods, you can prevent the misuse of data. Thus, when correctly implemented, a class creates a black box which may be used, but the inner workings of which are not open to tampering. Okay. However, the classes that were presented earlier do not completely meet this goal. For example, consider the stack class shown at end of chapter 6. While it is true that the methods push and pop do provide a controlled interface to the stack, this interface is not enforced. That is, it is possible for another part of the program to bypass these methods and access the stack directly. Of course, in the wrong hands, this could lead to trouble. In this section, you will be introduced to the mechanism by which you can precisely control access to various members of a class. However, a member can be accessed. how a member can be accessed is determined by the access modifier attached to its declaration. Java supplies a rich set of access modifiers. Some aspects of some aspects of access control are related mostly to inheritance or packages. A package is essentially a group of classes. These part of Java's access control mechanism will be discussed in subsequent chapter. Okay. Here, let's begin by examining access control as it applies to a single class. Once you understand the fundamentals of access control, the rest will be easy. Note, the module feature added by JDK 9 can also impact accessibility. Modules are described in chapter 16. Alright, we'll come back to it later. Java's access modifier are public, private, protected. Java also defines a default access level. Protected applies only when inheritance is involved. The other access modifiers are described next. Let's begin by defining public and private. When a member of class is modified by public, then the member can modified by public, then that member can be accessed by any other code. When a member of class is specified as private, then that member can only be accessed by other members of its class. Now you can understand why main has always been preceded by the public modifier. It is called by the code that is outside the program, that is by the Java runtime system. When no access modifier is used, then by default the member of a class is public within its own package, but cannot be accessed outside of its package. Okay. Then we have, in the classes developed so far, all members of a class have used the default access mode. However, this is not what you will typically want to be the case. Usually, you will want to restrict access to data members of a class, allowing access only through methods. Also, there will be times when you will want to define methods that are private to a class. Okay. Also, there will be times when you will want to define methods that are private to a class. An access modifier precedes the rest of a member's type specification. Okay, an access modifier precedes the rest of a member's type specification. That is, it must begin a member's declaration statement. Here is an example: public int I, private double j, or private int my methods. Okay. To understand the effects of public and private access, consider the following program. I think I will continue it next time around. Okay, I can just read it, right? Okay. So we have this program demonstrates the difference between public and private. We have public int p, default access, private access. Okay. Methods to access C, set C, get C. Okay, access test. So we have OB, A and 10. These are okay. This is not okay. This will result in error. Set C and get C. Okay. As you can see inside the test class, A uses default access, which is for the example is the same as specifying public. B is explicitly specified as public. Member C is given private access. This means that it cannot be accessed by code outside of its class. So inside access test class, C cannot be used directly. It must be accessed through its public methods set C and get C. If you were to remove the comment symbol from the beginning of the following line, then you would not be able to compile this program. Okay. To see how access control can be applied to a more practical example, consider the following improved version of the class shown at the end of chapter 6. Okay. So we create private and this. So push and pop. Okay, everything is done within here. Okay, as you can see now, both stack, which holds the stack, and top of stack, which is the index of the top of the stack, are specified as private. This means that they cannot be accessed or altered through push and pop. Making TOS private, for example, prevents the other parts of the program from inadvertently inadvertently setting inadvertently setting it to a value that is beyond the end of stack array. Alright. Alright. The following program demonstrates the improved stack class. Try removing the commented outlines to prove yourself that the stack and TOS members are indeed inaccessible. Okay, we create two stacks, push into two stacks. Okay, this won't be easy. Okay. So although methods will usually provide access to data defined by a class, this does not always have to be the case. It is perfectly proper to allow an instance variable to be public when there is no good reason to do so. There is good reason to do so. For example, most of the simple classes in this book were created with little concern about controlling access to instance variables for the sake of simplicity. However, in the most real-world classes, you will need to allow operations on data only through methods. The next chapter will return to this topic of access control. As you will see, it is particularly important when inheritance is involved. Alright, so understanding static. I think I should continue this tomorrow. Okay, so what will I be left with? This static final arrays nested in a class. Okay, variable length. Oh, okay. This variable length. Then we have inheritance, generics. Okay, library, string handling, collection. Yes. Okay.